Welcome to another video on our Basics of Optics series, and today we will be going over the spectrum and dispersion of light. So it's very common to see this principle of dispersion happening in a rainbow, but I'll explain more of why that actually happens later when we understand the concepts. So the first thing to understand is that light is actually a spectrum. So it's a form of radiation, specifically electromagnetic, that consists of different wavelengths. So this basically just means, it's a fancy way of saying that light is a form of energy and it travels in a wave-like pattern. The different colors we see during dispersion, which I'll talk about later, are just the visible wavelengths that this light energy can be. You can see in this picture on the bottom, we have a scale of the whole electromagnetic spectrum. Very important to understand that it is not just a visible spectrum. We actually have a lot outside of that, including gamma rays, which are shorter wavelengths, and radio waves, which are much larger wavelengths. So just keep that in mind. So let's talk about the dispersion of light. So this is the process of white light splitting into its component colors when it passes through a transparent medium such as a prism or lens. So white light is actually made up of all the colors of the rainbow, just like I showed you on the spectrum. All that visible light, if you combine them all together, you see white light, which is this light that comes from our sun or LEDs. Depending on the type of light, it may include some other parts of the electromagnetic spectrum that we can't see, but for the most part, it's just the visible light. So all the rainbow of colors that we saw in the picture before. So when light hits a prism, the prism refracts the light, which is just a basic understanding of how this works. In the animation below, you can see it happening, but let's go into more detail. So each different color of white light has its own wavelength. And although it makes up a very small portion of the electromagnetic spectrum, there is still differences in the wavelength, which is just the length between the waves. And this wavelength determines how fast it moves through the prism. So the longest wavelength, which is the color red that we can see, has a very slow speed, and violet has the shortest wavelength, which means it travels the fastest. The speed of each wavelength or color determines the angle that it refracts at. So you can see that red, as it's moving the slowest, it has a highest angle of refraction. Purple has slightly less angle of refraction because it moves a lot faster. You can see that this actually happens again after all those rays split. As they leave the prism, they are splitting again, which is widening the cone. So let's just recap here. You see in the image below that we have a prism being split, and obviously you can see the whole rainbow. So when it hits the prism and the light splits into multiple different colors, rays, wavelengths, each ray has a different wavelength, which affects the speed that it travels inside the prism, which determines the angle that it refracts at. Because they all have different wavelengths, they refract at different angles, splitting the white light into many different types, many different colors of light. Now this process happens again when the rays leave the prism, which widens the cone, producing the whole rainbow, which we can see. Now, one key note that I did not mention earlier is that light actually travels at the same speed through air, which makes sense because if they didn't, then we would have them refracting on every surface, and we'd only see rainbows. But because they move all at the same speed, they're cohesive, and it produces all the colors smashed together, produces white light that we can see. So here are some real-life examples. Of course, we have the prism, which is just glass, and it will change the speed of the light passing through. We also see this in rainbow, and like I mentioned earlier, so rainbow basically works when you have rain that falls down, and the light from the sun or from anywhere will start to hit those raindrops, and actually it will disperse within the raindrops. So all these raindrops together act as little tiny prisms. You can imagine that projects this whole rainbow for us to see. We can also see this happening on a CD. Hopefully by the end of this video, you can answer the 2 questions I have here on screen. Other than that, thank you so much for watching, and I'll see you in the next video.